in Slack. I'm going to go ahead and just post the presentation in your Slack. Again, the poster is Citizen. What's useful about the link is on each slide I do kind of give my reference material from a web perspective, so you can actually just go right behind me and recreate the experience for yourself. Also, I link all source code that I use within the slide notes. So again, anything you see here today, if it feels too rushed, you can kind of come back to it at your own pace. Again, I'm in your Slack. The name in there is Citizen. Feel free to just ping me if you have any questions after this is over with. Okay. So I'm going to be bouncing screens quite a bit. Let me get us through some warm-up material. Again, the presentation is going to be focused on portable executables and specifically how they look within Windows memory. The theme is it's going to be, again, kind of a slow walk, and hopefully we're picking up to a fast run as far as being able to deal with portable executables. Again, if you enjoyed today's content, I'd love to come back out and talk about how to deal with portable executables in memory from a programming perspective. Anything you see today, it's my private work. This is no way related to my employer. This doesn't reflect what it is we do in our practice. Again, this is strictly me talking to you guys. So a little of who I am. I thought I'd be a clever boy and do it like I was typing in a command line of Linux. If you guys are familiar with that. Again, my name is Peter Starfinger. I've got approximately 13 or so years in the industry. I've managed to achieve a couple of things academically, from professional certification to degrees. One time I did the maths as far as trying to figure out how many letters of the alphabet I acquired. There's something like 86% of the letters, so one day I'll get them all. From a work perspective, I currently serve as a cyber defense forensic analyst. I lead for my functional unit. I also serve as president of the local ISSA chapter. If you guys haven't heard of us, it's again a professional organization that's focused on promoting both contemporary knowledge on what's happening from an information security perspective, as well as developing the knowledge and skills of its membership. At this point, I believe there's a $30 fee if you want to join as a student. And what you get with that $30 is that each month we kind of put on two major things. One of them is our general session, where we bring in a local person to speak about InfoSec topics. And of course, we give you a lot of other enrichment, like what's happening that month from an InfoSec perspective that you should probably be concerned with. And then we also have a separate session that we call Tradecraft, and that's where we actually take you through a themed learning. You know, maybe it's ethical hacking, maybe it's exploit development. There's always a different theme. And then we take you into a learning environment, more than likely a CTF, where again you'll get a chance to apply some of those skills. Moving on, some other works that I've done. I've had a chance to participate in some industry research. There's a paper out there, I think it's hosted at NIST. It's my malware risk mitigation report. It's actually from many years ago, so maybe not so relevant today. But as you go down the list, there's some other work that I've done more recently, which, again, if you get an opportunity, I'll share some other links at the end where you can go back and view some of that material, because, again, maybe it'll spark an interest in you as far as considerations in your future professional choices. As far as today's presentation, again, I'm going to go through the layout of a portable executable. Then I'm going to talk about what it looks like from a kernel memory perspective to have a process loaded into memory. And then I'm going to also go through a bit of a mapping exercise where I show how a file actually looks within memory, again, in a very friendly way. It'll be pictures, that sort of thing. And then from there, we'll move into some kind of, again, easy stuff, Python basics. Then we'll dig at, again, using Python in combination with other tools, how you can go through the process of automating your ability to analyze a portable executable. So let's go ahead and get into this. You can see affectionately, I made this. Yeah, that's right, I art. That's why I have a day job. So, but kind of speaking to the art, what we're looking at here, if again, you're ever on your computer and you notice that, again, there's files with a .exe extension. Again, that is your portable executable. Portable executable conforms to a COF format, and it has something called a DOS stub. Effectively, what this means is if we're looking at the file, and we're reading from the very beginning of the file to the end, there's specific byte values within the file that give it its distinct characteristics, allowing the operating system to execute it correctly. From a DOS stub perspective, if you look at any .exe file, you'll find that the very beginning of the file has the letters MZ. That part of the file is what we call the DOS stub. Later in the file, there's something called COF stub, which is Common Object File Format. And again, this has, in the very beginning of it, the letters PE, followed by the byte, the hex value, 0, and then another 0. This section has pointers to another portion of the file that, again, follows sequentially, called a section table. And the section table points to all the pieces, parts, that are typically needed in order to load that file into memory so it's actually functional. After this, there's typically resources. Resources are things like when you're, again, on your computer, and you look at the desktop, you'll notice that files resolve to a particular icon. Again, that's all because of resources that are packed within the file. And then after the resources, there's typically something called an overlay. This is the one piece that's not loaded into memory. It's typically very unique to each file. And sometimes there's really interesting things there, sometimes not. Okay. Now, this is called an executive object. And the specific variant of executive object that I'm representing on the screen is called an eProcess object. And what's in the eProcess object is a lot of important information to the kernel, because from a kernel perspective, whenever a portable executable file gets loaded into memory, there's a lot of statistics that the kernel needs to track in order to understand, again, other files that are, again, in memory, potentially dependent on this. Also, things like, again, what maybe files or other memory objects have been created by the executable in memory that may need to be closed up before the executable is closed down. What you see in front of you, kind of, make sure I get the direction here right, kind of speaking from my right to the left, is typically when you look in kernel memory, you have something called a pool header. And what's important about the pool header is that if we were to take just a physical snippet of memory, the pool header also contains a unique signature, kind of like when I was speaking about the DOS stub, where you'll have in the very beginning of the file the letters MZ. You'll also find in kernel memory, in order to get to, again, the data structure that contains all the important information about the process. Again, you can look for I'll give you an example for Windows 7, PROC, and that typically represents the beginning of a pool header for a eProcess object structure. Typically, the pool header will point to other important information, such as what kind of an object structure will be within the file. And so this is mandatory. These are optional. And typically, again, The pool header will also lead you to an object header, which will have all the other informational stuff you need to interpret. Again, are we looking at a process? The reason why I share this with you is a lot of times you could look for, again, 4 letters, P-R-O-C, and potentially have collisions with other things that really aren't pool headers. And so from a memory analysis perspective, it's important to understand that there are multiple data structures that you probably want to validate exist in succession in order to know that you've actually found a legitimate structure within kernel memory. Building on that a little bit more, again, the eProcess data structure contains a lot of other useful information that includes things like when the process was created, where is the sections of memory that are devoted to that process, where can you find control information like what CPU registers are assigned to the block of memory, where all the stacks, heaps, and again, if this is your first go hearing about things that are important from a computing perspective, when code gets loaded into memory, just know that within the eProcess structure, a lot of those things are being managed. Now, moving to the right, again, I've annotated, there's a section of memory that's devoted to kernel space. This is typically where this eProcess data will exist. And again, include things like what CPU registers and that kind of minutia is needed in order for the executable to work in memory. There's also a little bit of shared information called the process environment block that will give other critical pieces of information to the code that's actually running in user space in memory. And that's, that bit of shared space is called a process environment block. Again, the other pieces that you have below this line, again, everything below this line represents what's available to user space. Includes things like, again, the very highest addresses, you'll have the actual file itself loaded. You'll have libraries that the file is dependent on. And then kind of as we go lower, we'll find all those segments that we mentioned earlier. And I have another graph that kind of has arrows pointing and connecting these things, but you'll find all the different segments we mentioned earlier that contain the pieces, parts, that actually makes the program function. Then as we get away from, again, the different segments from the file, we'll see all the dynamic things start to come about, like heap memory and stack memory and those kinds of things that allows a portable executable to function on a computer. I'm going to hit this, and then I just want to show another representation of what's in the eProcess structure, just because we're going to dig hard at what a portable executable looks like. But again, today we really won't be doing anything programmatically with memory. Again, this is kind of what the mapping process looks like. You know, I mentioned earlier, these arrows are a little bit light, but I mentioned earlier that, again, there's this space that's kind of for the kernel exclusively, and then there's, again, the user space where the actual content of the files will get loaded. You can see here, really what I'm trying to show is that all those sections that contain code and variables and things like that, again, those are loaded into memory, into different segments as they're defined within the file. You also have, again, it's not represented here, but that this original file is also loaded into memory, which can be discovered, which would include, again, your DOS stub, your COF stub, and again, the section table. Just taking a look, all the heap and stack segments, that's actually typically derived from information that can be found within these stubs, as far as what sizes are needed. Just come on the presentation quickly. Okay. Again, this has been shared in the channel, but what I want to show is one of the links is for Nursoft, and this shows a lot of these kernel structures. And I think it's just a great resource because it's freely available. On this page, if you search for eProcess, you get a closer look to see what's within this particular kernel structure that represents a process in memory. And again, as I mentioned earlier, there's a lot of statistical type things that are being tracked by the kernel. But for us as analysts, what's interesting, and again, I hope to get to this in a future presentation, are things like, when did the process first get into memory? When did it exit memory? One of the things that's interesting is there's, for instance, something called a doubly linked list, and all those processes that are in user space are linked up in kernel memory in this eProcess structure through a series of pointers. They make a long chain. Well, when a process comes out of memory, it's typically unlinked from the doubly linked list. However, earlier I mentioned to you there's, again, this idea of a pool header. And if you know what the pool header is that you're looking for, you can find processes in memory that are, again, in an exited state and potentially recover, again, all the volatile artifacts that were associated with that particular running process. So it's pretty useful. Again, you can see here's the reference to the process links, which is the doubly linked list. Let's see if there's anything else here that's worth a quick grab. Again, I mentioned earlier that there's also the VAD. And so, again, from a kernel space perspective, you know, the operating system is tracking, you know, what physical parts of memory are assigned to a process. But from a process perspective, a process, when it's loaded into memory, typically code expects that its address space is continuous and not all over the place. And unfortunately, one day I should probably come here and talk about disks, but unfortunately, kind of like a disk, when physical RAM is available, can usually be in multiple different physical locations from an addressing perspective. And so again, a VAD, or a virtual address descriptor, is the structure that's used to take all these disparate physical locations and bring them back together in one continuous addressing. And so instead of going 0, 5, 6, let's say those were the addresses, instead you would get 0 through 3 as an example. So again, here's just kind of an example of that. Again, you know, here's maybe how physical memory looks in reality. But from a process perspective, you know, the process thinks that everything it has access to is all just back to back and right where it should be, just like it's inside the file, right? Everything's just right back to back. But again, this is really the mess that the kernel is managing, which is, you know, the space that's allocated could be all over. So I'm going to dive into some Python basics to kind of help warm us up. The code that I've shared for this was written in Python 2. If you tried in 3, you're going to spend a lot of effort having to correct things, and so I hope to release a Python 3 version. But for your purposes, if you want to try out the code that's there, again, use Python 2. Again, from a Python perspective, help is a really valuable command. Effectively, what help reveals to us, if we are in Python, so I'm just opening an interpreter, and this is Linux. And then within Linux, again, we can ask for help on different function calls. And what you get is something that looks like a man page, and effectively it tells you exactly how to use a particular function call or particular module that you've imported. Just another quick example. There's a module called sys. If you use the import command to bring in the sys library as an example, the sys library allows you to access arguments. And so right here, it's telling you that, again, if you want to access arguments, somebody's passing into your command line program, it tells you that, hey, this is really in an array. argv, again, referencing position 0, references the Python script itself, and then anything that follows that will occupy other spaces in the array, as an example. And the point is that, again, if you use help, you can find really informative stuff that the people who have contributed to Python have put together. Kind of some other basics that are useful is that you can also use a type command. And what type brings to the table is that, let's say, again, we're coding and we're getting a lot of error messages on how it is we're trying to handle maybe a particular variable, right? And you're not sure what it is you can do with that variable or what it is. Well, you can use the type command to discover the exact data type that you're using. And so just as a very quick example, again, if I were to say test is equal to 3, now we all know that, again, that's an integer when we use a numeric value like that. However, let's say later in the program you're trying to figure out what it is you can do with test. We may need just a quick reminder. Again, type will let you know what kind of a primitive you're dealing with. And you can pair that with things like help to find out what other actions you can take on that particular primitive. So do take advantage of that. Again, that was type that I just showed, and you can use that against any variable that you've used within your Python code. And it's just especially helpful when you're inside the interpreter and you're trying to figure things out live. Again, I've already mentioned sys. So I did help on open, but I just bring up open because, you know, what's interesting about open is that open, the function call, you know, you can use without importing any other libraries, and it allows you to interact with files on the file system, and you can specify things like how it is that you read in the file. And so as an example, you know, in the code that I've shared, I asked that the file be read in as bits. And so when you look at the code, you'll see in the function call that, again, I named a file, and then it's a comma RB, which means read it in as a bit stream. Also, close is really important, and the reason why close ends up being really important in all your code is typically once you've loaded a file into memory, you probably don't need that file anymore unless you plan on writing to it or something else. And for our purposes, we're talking about interpreting PE files, so just I guess to kind of keep things clean, you know, close it if you're not using it, free up that space, free up, you know, and close those file handles that you've created. Also, exit, really key. Again, if we're going to have our code run gracefully, you know, the exit command is really useful. You can see that in the bulleted items, it's exit without any arguments. So again, when your code's done, use exit to indicate that, and you'll see that in the examples. I showed you an integer just to kind of, again, show the ease of Python. I'm going to show these 3 other data types. And so from a string perspective, you know, if we put anything in quotations, again, that represents a string. You can also do, I think this is Python 2, so it's probably going to be more forgiving. Yeah. Again, this is just me showing that, you know, without specifying that I'm using a string, depending on what I set a variable to, Python will automatically determine what kind of a variable, what the type should be of the variable that you're setting. Again, just like we showed earlier with integer, you You can also go in and ask for help on the type string as an example, and we can quickly see that with string, that there's a lot of function calls that we can use to manipulate a string. Like here, we have capitalize. We can again count and see how many characters are within the string. If we need to decode a string or encode it, again, those are all possibilities. The point is that if you, as somebody who's first trying out Python, don't know anything as far as how to work with data, take advantage of type and help so you know where it is you can go with, again, that particular primitive that you're dealing with. Just to show a list real quick. Now what's cool about a list is that if you look at what I just did, I put an integer and 2 strings inside of the list. And so unlike like if you were programming in C++ or C, like those languages are really rigid. What's nice about Python is that we can kind of mix and match what it is we're putting inside of arrays. You're not going to get punished for that, if you will. And anyways, again, if you're leveraging a list, again, there's many things you can do with the list that are very comparable to what I showed you at a glance using a string. And anyways, just here's some of the examples. We can reverse our list, we can pop things from our list. We can count how many things are inside of the list. When we think in terms of a list, it functions a lot like an array. Again, in code, you wouldn't do that, right? You'd probably want to call print if you want to look at the inside of your list. You can do other interesting things, like as an example, I could say, give me everything up to the second position, right? Or I could say starting from -1 up to 2. So -1 would be position 0, 1, 2, position 2 on the list. And so I don't know if you guys are seeing the syntax that I'm using there, but by using colon and positive or negative integers, we can refer to all the different positions within the list, and again, even ask for specific outputs from the list that are going to be most relevant to our work. I just have a tiny list, so that's not so interesting. Okay. Dictionaries. Yeah, and just a quick example there. So in this example, it may be a little more complicated than it needs to be, but the point is that if, let me just show you again, this is a dictionary. The point is we have a type dictionary. What that means is that I can do lookups, and I can say, hey, show me you know, what the key machine returns, and whatever follows the colon is what value would be returned if I were to query for, again, machine in this particular example. And again, if we just use help, you'll see all the different ways that you can interact with a dictionary. And then just from a comfort perspective, I think it's really useful, if you don't work with bits and bytes every day, I think it really is worth putting some energy into understanding that. The simplest way maybe that I could think to explain this is that when we think of a byte, typically that's 8 bits, and typically 1 byte is equal to a hex value of some sort. And so, as an example, if we were looking, we look at that as an example. So we can see MZ at the very beginning of the file. That's a process executable. And we can see that from a hex perspective, 4D makes the M, 5A makes the Z. Okay. In order to, again, get this value from a bit perspective, you would have to, again, have the right bits flipped in order to return a value of 4. And so this is actually, from a binary perspective, you typically would have, for an example, 4 placeholders, right, for a 1 or a 0, and kind of starting from right moving to left. The very first position is typically, if it's turned on, so a 1, that would be a value of 1. The next position would be a 2, the next position would be a 4, and then the final position would be an 8. If all those were 1s, you would add all those values up, getting a whole number value of 14, or the letter F. And so from a hex perspective, the way that it translates is that when you start at 0, and once you get to 9, right, again, still a number in hex, but once we exceed 9, you go to the letter A, and then 11 is B, and then 12 is C, and then, wow, I'm losing myself here, but 13 is D, and 14 is E. Moving back here. And again, I'll show an example of functions returns here shortly. So let me dig real quick into the example. Again, this is available to you. I'm going to show this very quickly, so kind of keep a move on here. Again, in the links, there's a reference to a Wikipedia page, and effectively on that page, there's a complete breakdown of what a PE file looks like from a bits and bytes perspective. And really what I want you to see here is that at the beginning, again, we see the 5A 4D, that's the MZ I was referencing, and that's the start of the DOS header. And then within the DOS header, at position 3C, that is typically where we will find a pointer to where the PE header is for the file, which is the cough section that I mentioned earlier. The way that in the example I'm going to show you, the way that we represent that from a code perspective, again, I end up defining a function called main. And in Python, again, what makes up a function is you start with, again, def space, whatever it is you want to call your function, parentheses, and then if there's any variables that you want to accept in your function call, again, you would put them between the parentheses and make them comma separated. Again, because of Python's simplicity, you don't have to define what kind of a primitive type it is by, again, saying, oh, this is an integer and this is a string. Again, it works very similar to what we did earlier. Whatever you set the value of that variable to is the data type that the variable assumes. And then again, in this particular example, I end up creating a variable that will end up being an integer. That's the number 0. And then I end up making, again, a function call to something called make byte array. Okay? And then I say from make byte array, I'm expecting 2 values to be returned. And so I have 2 variables ready to receive, again, whatever's returned by this function call. Okay? Make byte array, the only thing we're doing here is that we're actually reading in a file. And so again, we have the same play that I just talked about earlier. Again, we're using def to define a function. Again, this one's called make byte array. We're not expecting any arguments. And then anything that follows the colon, again, that syntax is very important, is going to be part of the function. Now, what Python, what's really important in Python is the way we do our indentions. And so in this particular example, it just happens to be 4 white spaces make up my indention. A lot of IDEs will take care of that for you. If you don't have an IDE that you like to work in, there's a free one called PyCharm. It's really user-friendly, and it'll help you with all these indentions so you don't have to remember things like that I use 4 spaces or 5 spaces or 3 spaces in my code. With that being said, though, let's move on with the function. And so for this particular function, I print a message back to the screen that says building byte array. And then I then go right into the business of opening up or defining a variable for a file that I'm going to open up. The way that I handle this one particularly is, earlier I mentioned importing sys if we want to deal with arguments. And so in the beginning of the code, I have an import statement for sys, and that's the only library that I import for this particular code. And then getting back to, again, the function call, I look at sys and I say, hey, give me argument 1. Now, again, I'm not a programmer. Typically, if you work in the security industry, you write code that functionally does what it is you need to do for the job, right? Like, you're not writing code for thousands of people to use. You're writing code to get a thing done, right? We got to dig a ditch. Again, let's write code that does that very quickly for us so we can move on to the next thing we need to accomplish. And so in this scenario, again, I look at whatever that first argument was that was passed to my Python script. I turn that into a string, and then I use my file to capture whatever that value is. I then take my file, I pass it to the open function, and I say read in bytes. Again, just like I mentioned earlier, using the interpreter can be very, very helpful when you're unsure of what your options are. Typically, whether I'm in Windows or Linux, I'll have multiple windows open, so I can just get right into an interpreter if I need to validate live what it is I'm doing will actually work. And so I can actually, again, take code that I'm working on, in this example, VI, put it in there, and then just see if Python yells at me. If it doesn't yell, you probably have code that might work. So, a bit of a pro tip there. Again, the open function call, if we weren't sure what it is we could do with that, we can go right into help. And this isn't as, Python 3, the open is much friendlier than this. Again, in this example, I'm reading in bits, and then I use F to capture the fact that I've created now a reference to a file where I'm able to read in those bits. Then I create a list effectively called bytes read, and then I tell Python to go ahead and try to read in, again, 1 byte at a time until all bytes in the file have been read. Now in Python 3, there's a little more handling that you need to do when you're reading in a file. This will not work, but for Python 2 purposes, by me saying continue executing this while we're not getting a null result, that is sufficient to break the loop. Again, just speaking a little bit to the indentation that's going on here. So we have try, and then everything that we're going to try, again, has to be indented. And so I, again, create another variable called byte to capture what it is I'm reading from the file, again, 1 byte at a time, and I say while that byte still has a value, again, colon, again, we have another indentation, continue to take those bytes and append them to my list called bytes read, which I defined up here. Again, a list, in order to add things to the list, you have to use an append function call. Again, if you were to use help against a list that you've defined, you can see these little subtleties on how it is you work with that particular data type. Presentation guys are being very kind to me today. That means they're not. Okay. All right. Again, moving along. So we'll continue reading until we reach the end of the file, and effectively, what this function is doing is it's populating a list that we can return back to the main function itself. Again, going back to the function called main, once we have that result, we're able to then pass it to another function called check.DOS_stub. We'll probably stop here. Effectively, I'm passing a list to this function together to see if the DOS stub exists. The DOS stub is MZ. So if we go back up to that particular function call, again, there's some variables that I just set to some default values so they actually become something of use by me doing the double quotes with no value. That makes header become a string as far as its type. I create something called LOC for location. I set that to the value 0, now making it an integer. And then I also use DOS header check, and I do this equal to the brackets, which therefore makes that a list from a Python perspective. I then say that, hey, while location is less than 4, and then I add another condition in within the loop saying that while location is less than or equal to 2, we want to add to our DOS header check whatever bytes are at that particular location. And then again, increment the location so we can get the next byte within the loop. And then when our location hits a value of 2, we then want to do the following conditional loop. And it says for every entry, now what's interesting about a for loop within Python is that whatever follows the for, this can have any name you want. The point of this is just to capture whatever follows in. So if what follows in is a list, what we're going to do is go iteratively through the list until we reach the end of the list, and each item in the list is its value is going to be assigned to, in this case, the variable called entry. Okay. We then say header is equal to whatever the current value of header is. Remember earlier we set it to null. We know it's a string, and so I'm just appending to the string each of the values that are inside of the list called DOS header check. And then finally what I do is I encode header as hex, and then I say make sure it's uppercase and compare it to this 4D 5A, because again, when we go to the public reference, we can see, again, this is the value. The way that I'm handling it, I'm reading it in as Little Indian, and so I'm reversing the values. But the point is that this is what we expect at the beginning of the file, and that is what I'm looking for. If that turns out to be true, and I return a positive statement to the screen stating that, hey, this part of it is true, and I exit the process called, again, DOS stub read. Now there's other code in here which you're welcome to look at, where I go through reading some of the other stubs and looking at the values there and interpreting, are those values correct, therefore proving to myself that this is a bona fide portable executable. The only other thing I want to point out from a coding perspective, again, you can look at this on your own, is that because I wrap everything up as a function, the way that I kick the whole script off, if you will, is by calling main at the very end. And that's just a small subtlety, and that's useful. And it's useful to you because you can take your code and modularize every function of your code. And so when it comes to, again, troubleshooting or anything, you know, if you need to turn off a particular function call, you can quickly do that by going to your main function and just saying, hey, you know what, let's comment this one out and make sure I can, you know, execute up to this point, and, you know, little adjustments like that, so you can troubleshoot whatever issue you might be experiencing. Just to show this very quickly in action. Again, we'll do juice. Again, this is what it ends up looking like as an example, is that people will abuse what we take for granted is a structure that's going to be used just as it's supposed to be, and it may not actually turn out to be that way. So understanding, you know, the structure of portable executables allows you to better interpret, you know, is this a legitimate program or is this potentially bad code? Everything I've just shown is just again, me dorking around with code, and I recommend you do the same thing to, again, increase you know, what your horizon is as far as using the Python language, because it is used quite a bit throughout the industry. And again, even though I've shown you all this, there is kind of a shortcut, and that shortcut is you can use something called PEfile, which is a module that you can import that actually exposes all these data structures to you to use however it is you deem necessary. Just to, again, show that, if you go to the next slide in the slide deck, again, it's called Python module reuse. You'll see me going through some quick examples on using it. While that loads up. So what I did was I went out to the directory Windows and then System32, and I just grabbed cmd.exe, because you really don't need to deal with malcode if you want to just be in the business of understanding how portable executables work. And so that's what I'll use for this particular example. Again, this is PyCharm that I'm loading up. I'm not going to go through the process of building a project. but I do want to show that once you have your project built, you do have to add the PEfile module to your list of libraries. The way that you would do that is after your project's built, just go to Files, Settings, and then in Settings, you go to Project Interpreter and click the little plus sign. Once you click the plus sign, again, search for PEfile. There's a lot of apparently other versions of PEfile. The one you want is the one made by Aero Carrera. You would just literally click Install Package, then it would add it. Now, for our purposes, because we were going through kind of a lot of work where I was pointing, hey, here's this chart you can look at, and then you can see the exact breakdown, and you can read in bytes and all that other business. That's great, but again, with PEfile, we can skip a lot of that. And so again, in PyCharm, we can go right to Python console. That's an interpreter that's actually going to be part of the PyCharm install. From there, I'll just do import on PEfile. Once PEfile is imported, again, we can use help to figure out how it is we use this module. Because I've already been through this, it's easy for me to cut to the chase. But again, if you took the time to do the same reading I did, it maybe takes 10-15 minutes because of how well a lot of these modules are documented. So for PEfile, there's a particular class called PE. And so the way that we would call a class from a module that we just used is we would say PEfile dot whatever class we're interested in. In this particular class, what we can do is, and again, it shows you can say, hey, you take a variable called PE, set it equal to, again, the module that we just imported, PEfile dot PE, which now references this class, and then we would just point it at whatever file we were interested in interpreting. And so for our purposes, I'll end up doing PE one of the nuances using this within Windows is that you have to escape all your slashes. Again, as I mentioned earlier, I just copied command.exe to the desktop. So there it is. Now effectively command.exe is now encapsulated within this class as an object, and now we can take actions on that. And so if we weren't sure, again, what those actions were, again, you can always use help. I'm going to save you from me scrolling through all this, but take advantage of help. Also, in the coding example, I have lots of little things you can try. And so earlier I mentioned, or in the example I was showing reading, is MZ there. Again, now you have a way to just quickly see, what's in that header. Turn on word wrap. So again, at a glance, right, we have, I'm sure if I were to check, this is probably a list, but we have, what the magic value is, again, 5A4D. That matches 100% what it is we saw back in the image, showing us, again, what we should expect at the beginning of the file. Building a little bit more on this, you can also read in all the other headers without having to code for those. And if you really just didn't have much time, but you just knew that you were going to deal with every part of the file, again, you can just do a full dump of all its contents, and everything will be printed out for you. Anywho, again, just using the command line, we're able to, again, run type against any of those particular substructures that are part of PE. And again, if I were to run help against that, you'd see specific info. The other thing that's kind of nice, if you're using PyCharm instead of Vim as an example, is that you can also see for all the variables you create, all the structures that are naturally a part of that object that you've now instantiated. And so if you didn't want to go through, like what I was trying to show just a second ago, is that if I take my variable, which I know is an object, and I hit dot, again, the IDE is automatically showing me what all my options might be as far as function calls or structure types that I may want to reference. Again, if that's not your desired experience using, again, an IDE like this, again, you can roll right to the right and you can see every variable you've created while you were coding within the interpreter, and dynamically look to see what all the values and options are with that particular variable. Again, moving forward, I'm going to show you just a couple more tools. A tool that kind of takes this and weaponizes it, as an example, something called PEscanner. PEscanner, if we were to look at the code, we've been here for a little while, so we're not going to look at it tonight. But if we were to look at the code, again, it's just importing PEfile and using all the built-in functions of that in order to, again, make a higher level determination. Are you dealing with malcode? For those of you who have read Malware Cookbook, this is PEscanner from Malware Cookbook. And again, what it's giving back to us, and this is everything you can get out of PEfile, is all the header info, about the file itself. We also get, again, what is the entry point as far as the actual address you're going to go to, and the starting point for all the code. Sometimes this can reveal really interesting things to you. We also can see from an AV perspective, do we have any signature hits? Apparently ClamAV thinks there's something funny about the file. We can also see all the individual sections and see things like, as an example, something that's defined within all these headers are things like what should the size in memory be versus what is the size while it's still a file. Like an easy indicator for malcode is sometimes you'll have a physical size of 0, but then you'll have this really large size within virtual memory. And if that's ever happening, you're probably dealing with a packed file. Other things that are interesting that are being revealed here, as an example, is something called entropy. And if I were to open this up just a little bit, I bet it'd display much better. So again, you get something called entropy, and it's still looking like I have a carriage return there. But the closer you get to a value of 7, the more packed, if you will, the code is. And so that's sometimes an indication that maybe you're dealing with encrypted or compressed data. The point is that, again, all this is exposed to you through the PE module. And again, as in the security profession, these might be understanding that you're able to read these things about the file. Again, using a Python coding environment can better help you determine what's good, what's bad, what should you spend your energy on. If you can imagine, you can actually assess things in mass, because again, with the coding language, we're able to automate. I didn't get to HXD. Just to flash that on the screen. Again, please look at this in your own time. HXD is just a text editor. Install it on this box. Again, it's available in the download links for you. Again, it's just a hex viewer, but what's useful about that is that, again, from a command line perspective, you saw that I was using a tool called XXD to view things in hex. With HXD, it's a visual hex viewing tool, and so you can, again, if you're in the business of coding and you're trying to read things in as a binary stream, it helps to be able to see that in a hex editor to go, well, am I reading this incorrectly? Is that actually the value that I should be getting at this point in the coding process? Moving forward, some other industry tools that are worth taking a look at. Again, I provide links to all of these. They're in the Slack channel. Is PE Studio, that kind of builds a whole lot in PEscanner. It's more of a graphical tool for Windows, and again, it parses out all these different sections of a PE file that you might be interested in. Resource Hacker, again, there's typically a part of a portable executable called resources that may contain icons, or it may contain other executables in there. Well, Resource Hacker gives you a chance to dig at those and see what those attached resources might be. Also, Process Hacker. Process Hacker allows you to see memory in a way that Task Manager doesn't expose it to you. Finally, we talked a lot about structures in memory. I linked Volatility Framework. They have a very nicely written wiki. What's great about Volatility Framework is that, again, if you are able to get a copy of memory, you can then take that memory and look at these kernel structures and understand all these little tidbits of information that I was sharing. Then finally, WinDBG and KD. Again, if you wanted to do kernel level debugging while you're looking at something live, these are great tools for that kind of work. Also WinDBG, because the nature of it, it downloads symbols for your operating system, so you can just independently spend your time looking at all the different components of a data structure, of different data structures that are within memory. All right, guys, I appreciate your time. Again, I'll try to drop some links where you can find other useful information and do this on your own. You know, again, if you have any questions, definitely reach out to me. This is my first go trying to present on this particular topic, so I appreciate you guys listening through on it. And again, if you're able to privately give me any feedback, I appreciate it. Thank you, everyone.